My name's Adam Luciano, and this is Chad Piper. And we're part of the technical team for SETC, which is working in the auto industry in the blockchain. So what we're going to walk through basically today is what the blockchain ecosystem looks like, explain a little bit about what SETC is, and then also we're going to talk about a little bit about Cellchain as well at the end. So what is SETC? So what we're basically looking to do is we're basically taking the entire auto industry and we want to move it into a blockchain environment. To do that from a blockchain perspective entails a significant lift.
Yeah, we getting audio?
Can you guys hear me?
No audio. You got to move up.
Okay. A little closer.
Yeah.
Okay, so what you see in front of you is a basic depiction. It's a multi-staged approach, but a basic depiction of what the SETC, ecosystem is.
Can you start? Just.
I'm putting it on.
Okay.
So
okay.
for everybody, just if you guys who didn't hear me, what we're looking to do is we're looking to move the auto industry, all the different components of it, onto a blockchain ecosystem. To do that requires a significant amount of lift, technical lift, and also scalability. So current blockchains don't, there's things like Ethereum, there's things like EOS, and some of them are older, some of them are newer. So what we're basically doing is we're doing a phased approach to be able to hit this vision. So what I want to walk you through is what you see here. This is kind of complex, but the basic idea is that this is a multi-chain system in the end, which basically allows you to,
There you go. Push that button on top if you want to use it. The laser.
Oh, perfect. This is a multi-chain ecosystem that basically allows multiple blockchains to connect each other and pass, this is key, not only value, but data as well, arbitrary data, it can be anything. How are we going to actually start this out? So what we're going to do is we're going to start out and fork the Ethereum blockchain. And we're going to leverage a proof-of-stake mechanism called tendermint. That's basically a consensus mechanism to arrive at finalizing blocks and committing blocks to the blockchain. So that's the first basic thing. So we can do that right out of the gate right now today. What we're going to look to do with that is it enables us to have smart contracts and also can utilize the developer ecosystem that's been built up around Ethereum to effectively utilize some of the aspects of it. One of those being something called plasma cash. This is a sidechain technology, and what this basically does is it allows you to execute transactions in a much faster way that has the security of the main chain backing it up. So if I want to send a transaction to Chad, for example, on Ethereum today, it might take 30 seconds or 60 seconds or something like that, depending upon what the load is on the chain. In a plasma chain, something like a plasma chain, it would take like a second, really, really fast, if not even faster than that. So you can execute things much faster. And the reason why we want to do this is because we want to be able to execute things very quickly and at very, very low cost. So we're going to incentivize the users of this system, basically people like me and you, who are going to be, let's say, car owners, or let's say carpooling system, like something like an Uber, is basically in the sidechain. So we get the benefits of a blockchain system, but we get the benefits of scalability from a sidechain technology. So I'm going to move forward a little bit to kind of phase 3, which is this. So for those of you who have never heard of something called Polkadot, it's one of the projects that is being built in the ecosystem for interoperability. So that is basically connecting multiple chains together. In my view, there's two basic technologies in this space that are pretty good and trying to do kind of the same thing. One of them is Cosmos, which actually developed the tendermint technology, which is the consensus mechanism we're going to use in the Ethereum piece. And then there's also Polkadot, which is parity technologies, and the kind of the differential there is that you could use consensus, what they call consensus as a service. So the blockchains that can connect to it. So if you kind of picture this little square here as another blockchain, they call it a parachain. What it basically does is you can actually inherit the security of the overall consensus mechanism. So there's basically one consensus mechanism and multiple chains connected to it that can leverage it. If they don't want to necessarily use it, that's totally fine. You could use something called bridges, which is basically you could have your kind of consensus and just pass information within the chain. The reason why we chose this design approach is because since there's multiple different industries, so we want to connect like financing, like car insurance, car maintenance and repair, manufacturing, supply chain, just a couple of examples. So to connect all those things together, you need to facilitate a system where they also have control as well to have kind of how it might work. We don't want to necessarily dictate to them that, we don't want to necessarily dictate to them that this is how you actually have to build it. So what does it allow you to do? It allows you to create permission chains, it allows you to create private chains, and then expose, let's say, certain aspects of it to the ecosystem and not, which is a key benefit here that we want to drive home with the SETC ecosystem. The other benefit here is that because of the Polkadot technology, we also have the ability to move value and also data across into other chains as well. So that could be the native public Ethereum chain. It could be things like IBM Hyperledger or other blockchains that we build that are basically building bridges to it. So this is you can kind of call like a blockchain 3.0, where you get the ability to connect multiple different industries together. You also get the ability to connect to other systems that are current. And you get the benefits of utilizing things like sidechains where it makes things really, really fast. So it solves a couple different issues around scalability, and also because it's on a blockchain, you have the increasing of the transparency. So under kind of at a higher level beyond all the underlying blockchain infrastructure is the database and the data marketplace that this is going to enable, the trading information that this is going to create. So we're looking to leverage a technology called Big Chain DB, which will utilize its own consensus mechanism, but which is retenderment. But what basically allow you to do is you have a database, and there's every single entry into that database can be through consensus. So you have the immutability aspect and the data trail, and we're going to also create other mechanisms around it for data provenance, which is basically where data comes from. So on top of that, you're going to be able to access or utilize that data for AI, ML type stuff. So this is going to be really key in the way into the future when you have like autonomous vehicles trading, let's say, data back and forth. We're obviously going to be able to leverage oracles and those types of technologies that feed data to the system. So all these things kind of coalesce together into a way to not only facilitate all the benefits of blockchain, the interoperability between this chain and other chains, but also have the mechanism of a data marketplace built into it that's specifically designed for the auto industry, but also can be leveraged in other areas as well, which we'll talk about a little bit with cell chain. So Chad's going to talk a little bit about the actual database technology.
So Adam hinted to the AI, the machine learning, the data that actually is you're incentivizing. So I want you to imagine this is a real thing here. We actually have a device here, a smart device that is in the cars right now. I mean, a couple thousand, at least 2,000 we know of, maybe 4,000. And so it's collecting tons of information. And so this is a picture of the actual device, and it shows you that you have quad sensors around the car and the mirrors, and so that it's collecting all bits of information internally. There's information, it's a little box that's in the back of the vehicle. And so all this information, if you have, let's say you have 100,000 people that are driving vehicles, now you can incentivize the auto industries are looking for data sets for maybe a Toyota Prius. And they're trying to do, as you know, autonomous driving vehicles. Tesla hasn't done, Uber and Tesla, they've tried to do this, and Google also, and it's not a very easy problem, okay, it's difficult. Imagine now, for example, that while you're driving and the machine is collecting all this information and all the decisions that you're making as you're driving, that the car is able to correlate that information with what the car would have done if it were driving alone, and then kind of compare and contrast. So the idea here is that in the previous slide, we're hinting to how this information that's being collected by a user going through the ecosystem, stored in a blockchain database that is associated with the user. Marketplace is not shown here, but ultimately, if you take 100,000 users and you take that data now, which is the data was collected through this device. Now what you have is a way to sell data that you wouldn't have before, right? So the areas are, one, blockchain data entry. Obviously, the ability for a user now to transact on a blockchain by just driving the vehicle, which is collecting all the information, is a good use case. Imagine that you're backing up the car. So when you back up your car, you usually use a camera, and you think, well, the camera's there, it's doing it, but there's a lot more that's going on. Now, this box is collecting all sorts of information, what the weather is, where you are, what the context is, who's around you, how fast you're going.
Mm-hmm.
And all this information is extremely useful to the auto industry, who wants to take this information at scale and analyze it and make correlations with human-computer interaction, computer behavior. Driving behaviors, public safety, increasing a revenue, because now when you're just driving your car, you're going to get tokens, you're going to get some sort of money, incentivization, some payment for actually sharing that data. And so here, we talk about contributing data, meaning, you have this device in your car, you collect this information, you own and control it, you share it, you can actually get some value for it. Now, Mr. Fang has been an investor and also a key facilitator for the SETC project. Another project that we're working on as well is called cell chaining, and we're going to be leveraging the ecosystem that Adam just introduced in the cell chaining project.
So I don't have that much time, so I'm going to move through this a little quickly. But effectively what this is that you're going to put your DNA or genome basically on a blockchain. So what does that really kind of mean? What that basically means is that it allows now that data to be accessed and utilized by artificial intelligence machine learning. Okay, and then for also to facilitate the data the transactions of value that are associated with that. For example, let's say, for example, you're a person, you have a specific type of, let's say disease, let's say rare blood type with associated interesting things, let's say in your genome. That data might be worth a lot of money to pharmaceutical companies that want to utilize that own data in something like, trying to figure out if a certain drug might cause some sort of side effect with it. So there's kind of some interesting things here where we could leverage a whole new data set and not only provide value to the organizations that want to leverage it, but also provide value back to the person that has it. There's a lot. This kind of describes a little what I was just talking about, but there's a significant amount of mechanisms here in scientific research that can be leveraged or something like this. So what I wanted to also talk to you guys about was, I mentioned before something called the zero knowledge proof. We could leverage something like that in verifiable computation to basically preserve privacy of our own data against companies that actually leverage it, right? So that ties into also something called homomorphic encryption, which basically is data that you can kind of transform, and when you run a data analysis on it, the results are effectively the same as if you ran it on the original data itself. So that type of technology will be leveraged in systems like this. So what have we gone to now, and where are we going to in the future? Real quickly, we're building up our communication group. We have 300-500 people in our WeChat group, about 60,000 addresses or 40,000 addresses, moving up in the future about 70,000 to 800,000. And then also we want to let you guys know that there is an app that is out there today that creates, you can interact with the blockchain and also interact with the community as well. So I went through that rest part really fast, but if you guys have any questions, please feel free to ask us. Thank you very much for your time.